Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 4, Section 3, Part 6. And today, as promised, we're going to talk about some acid-base reactions. And again, if you remember, we've got an acid and a base react to form a salt and water. So let's first talk about the components of an acid-base reaction, the reactants, the acids. So in an acid, please write this down, it is a compound that dissolves in water to make a solution with more hydrogen ions than pure water. So when we're talking about acids and bases, hydrogen ions are the name of the game. Redox, it was electrons, this, hydrogen ions. Okay, so what are the properties of acids? They are sour. For example, citric acid in lemons has a sour taste. Also, they react with metals and give off hydrogen gas. So if you put hydrochloric acid and magnesium together, you will get magnesium chloride and then hydrogen gas will be given off. Also, acids are corrosive. Acids corrode. They corrode metals, which is what happens during this reaction. They will corrode your skin and most other things that any strong acid gets in contact with. Acids have pHs less than 7 on the pH scale, which goes from 0 to 14. 7 is neutral, below 7 is acidic. Let's look at their counterpoint, bases. So a base is a compound that dissolves in water to make a solution with more hydroxide ions than pure water. So it has fewer hydrogen ions, and you know water is HOH, so if you have fewer hydrogens, you have more of the second half, OH. So more hydroxide. This OH is hydroxide. So what are the properties of bases? Bases taste bitter, like baking soda. If you've ever tasted baking soda, it is bitter. Or soap, if you've ever had your mouth washed out with soap, it doesn't taste very good and it is bitter. So bases also feel slippery. So if you have some soap or another base on your hand, it will feel slippery. So bases neutralize acids. So acids neutralize bases and bases neutralize acids, which means their pH will go to a neutral pH like 7. And bases are going to have high pHs. They're going to have pHs above 7. So, what happens during an acid-base reaction? So, the general formula for an acid-base reaction is you get an acid and a base react to form water and a salt. So, it's not always sodium chloride. It can be, but there are so many other salts in the world. Let's look at a very common acid-base reaction. Hydrochloric acid, which is aqueous, so please write down this chemical equation, reacts with sodium hydroxide, which is also aqueous, to form liquid water and aqueous sodium chloride. So we know that this is the acid, this is the base, this is water, and that's the salt. So the definition of salt is a compound formed from a negative ion from acid and a positive ion from a base. So the real definition of a salt is the negative ion from the acid and the positive ion from the base. Okay, let's take a look at it with some color. So we know the salt is the negative ion from the acid, which is over here, and the positive ion from the base, which is the positive ion, and that comes from the base. And then if we look at the other elements, we have hydrogen from the acid, hydroxide, OH from the base, and you get HOH or H2O. And then let's rewrite this again with colors. HCl from our, I think we have our colors backwards. Just give me a minute. Okay, that looks a little bit better. We have our HCl, and that negative ion is going to form part of the salt, and sodium hydroxide, our base, and that positive ion is going to form part of the salt, and then the rest makes water. So acid-base reactions don't involve electrons, only hydrogen ions are moving around. And then the pH scale. So the pH scale measures if the compound is acidic, neutral, or basic, and it goes from 0 to 14. So the pH scale actually measures the hydrogen concentration, and we'll get into this in fourth quarter, but it's actually the negative log of the hydrogen concentration. And it's a logarithmic scale, so like a pH of 1 is 10 times more acidic than a pH of 2. And then a pH of 1 is 100 times more acidic than a pH of 3 because it's 10 times 10. Okay, just to recap, pH scale goes from 0 to 14. 0 to below 7 is acidic, 7 is neutral, above 7 is basic, and that pH scale measures the hydrogen concentration because that tells us how acidic something is. So let's kind of see where that comes from. So we have water, and it will naturally dissociate into OH and H, OH negative and H plus, naturally, just a little tiny bit. This double arrow means the reaction can go both ways, and the heavier arrow means that almost all of it is water, and just a little tiny bit of it is broken up into these ions. Okay, quiz time. You're going to classify these as acids or bases: bathroom cleaner, baking soda, lemon juice, and stomach juice or gastric juice. Okay, looking at our example, hydrochloric acid, we know acids dissolve in water to give more hydrogen ions than neutral water. So here's that hydrogen ion that the chlorine's going to form. And we know that they're going to taste sour. They're going to give off hydrogen gas if you react them with metal. And they're going to corrode metal and a skin corrosion would feel like a burn. Okay, here's our example of a base, sodium hydroxide. And that is going to dissolve or dissociate when you put it in water into our sodium ion and OH. And we know that bases dissociate in water to give off OHs. And then if I have a bunch of OHs, they're going to zip up those hydrogen ions that natural water just breaks up into a couple of them. And then it's going to make water. So I actually have fewer hydrogen ions. And that's what happens when you add a base, is that your hydrogen ions go below what natural water has, what neutral water has. Okay, as we know, we talked about bases are a chemical that dissolves in water to create fewer hydrogen ions or more hydroxide ions than neutral water. And just a quick review. When you put an acid and a base together, and remember this happens in an aqueous solution, so everything is dissolved in water, and both of those dissociate into their ions. You get hydrogen and chloride ions, sodium and hydroxide ions, and then this and this react to form your salt, sodium chloride, and then this and this react to form your water. And looking at our pH scale, we go from 0 to 14. 0 to 7 is acidic, 7 is neutral, and above 7 is basic. And this means you have lots of hydrogen concentrations, and this means you have fewer hydrogen ions. All right, so you should have read this last section, chemistry and movies. And please write this down. Many special effects are carefully controlled chemical reactions. So you should write down explosions, and you should be able to tell me, how are some explosions made in chemistry? How is eerie fog made in movies using chemistry? How is sparking and glowing made in movies using chemistry? Okay, a review of this third section. We talked a lot about chemical reactions that use aqueous solutions, which are dissolved in water. The two main types we talked about were redox, which involves the transfer of electrons, something being reduced and something being oxidized, and acid-base, which involves the transfer of protons, which is a hydrogen ion is a proton, and then you have an acid and a base, and it results in salt and water. And we use the pH scale to see if a aqueous solution or a liquid is acidic, neutral, or basic. And that means our chapter 4 notes are finished. Good job, everybody.